Preeti. We are here with the another question of exercise 7.1, page number 118, question number 8. In a right angle triangle ABC, the triangle ABC, this one is right angle at the point C. M is the midpoint of the hypotenuse, this one AB. C is joined, then this C is joined to M, this one, and produce to a point D, this one, and now DM is equal to CM, this one is equal to this one. Now point D is joined to the point B. So now we have to show these four things as given in the question. So start with first one. First we know that M is midpoint. So BM is equal to the AM. Now start with the first one. We'll have two triangles, triangle AMC and the triangle BMD. Now the triangle AMC, this one, and the triangle BMD, this one. Now we are having these two triangles. Now we are going to write here angle AMC is equal to the triangle BMD. This and this, these are vertically opposite angles. And now comes to the second point. CM is equal to DM. This CM is equal to DM. They are equal. This one is given in the question. Now comes to the third one. AM is equal to BM because this is the midpoint. So AM is equal to BM. So the triangle AMC is congruent to the triangle BMD by side angle side congruence rule. This is the part 1. Now comes to the part 2. Now in the part 2 we have to prove that the angle DBC, this one is the right angle. We have to prove this one. Now since triangle AMC is congruent to the triangle BMD, we have this one. So the angle MAC is equal to the triangle MBD. The triangle A and the triangle B, this one and this one, they are equal by CPCT. As we know that AC, now if this angle and this angle, they are equal but they form a pair of alternate interior angles, then AC is parallel to DB. Now BC, the BC is transversal which intersect parallel line AC and DB. We are going to continue this one here. Now BC is transversal. Now this BC becomes transversal which intersect parallel line Now we have two parallel line AC and DB. AC and DB. B. Now these two lines are parallel to each other. So the angle BCA plus angle DBC, this one is equal to the 180 degree because they are co-interior angles. Now comes to the part 2. Now in the part 2, since the triangle AMC is congruent to the triangle BMD, this one we have proved in the part 1. So the angle MAC, this one is equal to the angle MBD by CPCT. This one, the angle MAC, the angle MAC, this one is equal to the angle MBD, the angle MBD, this one is equal to this one. So we are going to write here, but they form a pair of alternate interior angles. Then so AC is parallel to DB. Now if BC is a transversion, which intersect parallel lines, AC and DB. So the angle BCA is the angle BCA plus angle DBC, this one is equal to 180 degree because they are co-interior angles. The angle BCA, the angle BCA, this one, the angle BCA plus angle DBC, this one. If we add them, they will be equal to the 180. But angle BCA, this one is equal to 90 degree because right angle at the point C. So angle DBC is equal to 180 degree minus 90 degree. So this one is equal to 90 degree. This one is the part 2nd. Now comes to the part 3. Now in the part 3 we have to prove that the triangle DBC, the triangle DBC, this one, this whole triangle, this one is congruent to the triangle ACB, this whole one. Now in both the triangle BC is common, so we are going to write here. First we are going to have two triangles, the triangle DBC and the triangle ACB. Now we'll have two triangles. Now BC is equal to BC, common. We are having this one as common. Now the angle DBC is equal to the angle ACB because they are 90 degree. Now comes to the third one. In the third one, AC is equal to BD. This AC is equal to BD. Why? Since the triangle AMC is congruent to the triangle BMD, then by CPCT AC is equal to BD. So now we are having two sides and one angle as equal, so we are going to write here the triangle DBC is congruent to the triangle ACB by side angle side congruence rule. Now this is the part 3. Now comes to the part 4. Now in the part 4, as we know that the triangle DBC is congruent to the triangle ACB. Now these two triangles are congruent with each other. So DC is equal to AB by CPCT. DC is equal to AB. This one, both are equal by the CPCT. Now if I am going to write here, CM is equal to, this CM is the half of CD or DC. This one is the half of DC. Now we can use AB at the place of DC because they are equal. So CM is equal to half of AB. So this one we have to prove. So we are going to write here, hence proved. So with this one we have completed the question number 8. In the next video we are going to start with the exercise 7.2.